is. So in a nutshell, the information that is commonly required by the treatment and disposal facility. This is just a common one. You do not need to cram these ones because as we talk about characterization of waste, you realize that this stuff is repeated in them. So when you're receiving the question you just asked me, how much is there? What state is it? And it is what is the pH of it? So basically, the facilities that receive waste would want to know such questions as: is it solid or liquid? Physical description. Does it react with water? Is it soluble in water? What is the pH? And we talked about pH a lot last time. Does it ignite? And the present the 4 characteristics of waste. So what are the 4 characteristics of waste? And this is according to the Environmental Protection Agency. But I want you to pick simply the 4 characteristics as such of waste. Actually 5, the 5th one becomes even more detailed. This we all know. In fact, we are scientists, we have learned English, we've gone to school and understand aviation. So the question is, does it ignite? Can it cause fire? Potential to cause fire. That's all. Characteristics of our waste as you receive it now. We have talked on phone. We have told you 1 or 2 things about it. Among the things you will ask me now is, does it cause fire? But as I'm bringing it, I should also be able to indicate that it causes fire. So it can be a liquid, it can be solid, but the question is, does it cause fire? So I said a number of things that are there will be repeated, oxidized and all that. The point I want you to carry home is, does it cause fire? Does it have potential to cause fire? The other characteristic is it corrosive? Okay, and this will depend. Remember pH, we have already mentioned up there. Is it what's the pH? Ignitability. So is it corrosive? So this depends on the pH. And you don't have to cram these ranges, but we are told and found here that the pHs that are defined as corrosive. And this is why it is important to label or indicate the waste pH. And so the facility that is receiving it can be able to know whether it is corrosive or not. Then there is reactivity. Sometimes we confuse reactivity and flammability, because if it can react, once ignited, it's burning, it's ignitable, so it's reacting to oxygen. Yeah, but here we talk about substances that are unstable. Again, remember the list that I've just shown you? Is it soluble in water? Is it reactive to water? If exposed to air, can it react? Does it detonate? Can it just explode? Okay. If any gas was around it, can it give products? So reaction, can it react to anything? So that is a characteristic of your waste. As you take your waste from the lab to the disposal facility, you need to inform them, as I bring this, be careful. It can react to water, to air, to gases, and so forth and so on. And then finally, last but not least, is it toxic? Is it toxic? Now, toxic, another abbreviation we're meeting today, is toxicity characteristic leaching procedure. This is the test that your material needs to pass. If it fails this test, then we say that it is toxic. If it passes the test, then it is not toxic. So ultimately, you remember the the sheets that we had, they indicated the toxicity. And sometimes we talk about toxicity with relation to the rats. We also mentioned the rats last week. If they can die under some dosage of that waste. So if the toxicity level can be given or determined, then you would be disposing of material characterized as toxic. In principle, we are saying there are 4 main ones, and I'm bringing in the 5th one, which also kind of is not conforming to the 4, or rather it can overlap. So ignitability, corrosivity, and toxicity, they become the 4 characteristics of waste disposal as you take your West. But now there is a fifth one. We had talked about fire being in class. Here we are saying listed. It's not classing as such, but listed West. So what we're saying here is that a material may not exhibit the characteristics that we have mentioned. It may not. So it may be toxic, it may not be toxic. It may be corrosive, it may not be corrosive. So we don't know, but we're saying even if we cannot classify them or characterize them as such, then we can classify them as listed waste. Listed waste means that we are under the guidance of EPA to just define them as listed waste. So there are very many listed lists rather, but EPA has given us three main ones that within our scope anyway of this class, we will talk about three of them. This is the most common one that you have encountered. This is just non-specific sources. So I'm in the lab. You remember our titration class, spent solvents. We have already mixed things here and there. We have worked with them. So we have remembered that we need to have the right labels on the containers that we are using. So these are spent solvents. We have already worked with them. We will define these as F lists.
In your
notes, it's not for you to start remembering that methylene, chloride, tetrablamla, that's not important. What is important is that you can use an example from the class to give a spent solvent. And titration is a basic experiment that we are using that you can also refer to and talk about the sodium hydroxide solution, the hydrochloric acid solution that you already have used. So that is the main one that you'll remember. Otherwise, U and P, which I just present in passing and say that the U and P, which are just hazardous waste, or absolutely hazardous waste that have not been used. Once you recall that, you should be safe to respond to the list F, U, and P, where F is spent and U and P are hazardous, only that P is acutely hazardous and they have not been used. Once they have been used, then they become F list. And remember that as we talk about F list, U list, P list, it is still possible that this waste is toxic, this waste is reactive, this waste is corrosive, this waste is irritable. So the listed waste is just a way of characterizing waste other than the obvious EPA definitions, the four that I have mentioned. I do not know if there's any question up to that point. Raise up your hand if there's any question. Right. Fine. I would like to engage you on something that you do every other day. Kama umekunywa chai asubuhi, inua mkono.
Kama umekunywa chai asubuhi, inua mkono.
You have already taken tea this morning. I know it's just 9:30 going. Some people have taken tea, others have not. If you have taken tea, raise up your hand. Okay. Now, so Prof. Alon, put your hand down, thank you. If you have not taken tea, raise up your hand.
Tuinue mikono.
I like that. I hope you don't expect my next statement to be if you have not taken tea, I'm going to invite you for tea. So a number of us have not taken tea this morning. That's what I read from what you are saying. Now, I will not ask this question because the answer would be everyone would raise up their hand. The question, the statement would be if you took tea yesterday. So chances are very high that you took tea yesterday. Can I speak to you, Wangoko? Unmute. Wangoko, did you wash the cup that you used to take tea yesterday? Yes. Why? To clean it. Okay, thank you. Yeah, thanks. That's straightforward, and you're just cleaning it. Unmute Sarah.
Utaitwa wewe.
Sarah,
Kwani naonekana niko huko?
can you hear me? Sarah, your reception is not very good. Let's try Ndwati. Unmute.
Ndwati.
Hello, Ndwati. How are you? I'm fine. Okay, Ndwati, when you take tea and finish the tea, is that cup empty? Empty.
Pardon.
If you take, is that cup empty?
Yes.
So if it is empty, why? Okay. Let's what is to this.
Nani?
Let's go to the chat box. I have taken my tea. I have finished every drop of tea in the cup. Why am I cleaning the cup? It is empty. He says it is empty. Why are you cleaning this cup? You see the reason why you people wash cups? Najua wengine hata huwa mwash vikombe.
Unaoshanga kwa nini?
Give us some reasons why you are cleaning the cup.
1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, 5.
Hygiene
1, 2,
is
3.
being given as one reason why we are cleaning the cup, so that you can reuse it for another time. This is what is coming from you. You can reuse it. So it means that usipoosha kikombe uweze itumia, then I don't know. To remove the stains left on the cup after taking the tea. Yes, that is another reason. You're removing the tea stains. You're removing tea stains. So, yes, then now the question is this cup empty? Now let's just type yes or no. For use later, make it free from contamination. Now tell me yes or no. Yes or no. Is the cup empty? In your view, no. Chete says no, the cup is not empty. No, the cup is not. Yes, the cup is empty. No, the cup is not empty. Thank you very much. Many people have said that the cup is not empty. And that is basically why you are cleaning the cup, because the cup is not empty. Why am I using the cup? We have had tea used to take tea in this class. It's because of what you're calling disposal of empty containers. When do you say that it is empty? When do you say that this is empty? You have used the cup, you have taken all the tea. Hata ukiangalisha chini hakuna drop moja iko kwa. Yet you're going to clean the cup. Why are you cleaning a cup that is empty? So it is not empty. That is true. The answer is
Gani?
Hata wifi yangu imeamua kucheza.
Mnaenda intense.
using the lab, the volumetric flask. When you complete your experiment, they are not empty. This is why you go into rinsing. So what you collect as you rinse the rinser is waste, it's a hazardous waste. And we saw that in the titration class, or rather, when we were talking about waste last week, we said after we have done our titration, we're going to clean our apparatus. What happens to the rinsed? We are supposed to
Kwani zetu zimenyamaza? Mimi nikikaribia tu hapa kwa hii mlango, lazima simu yangu isije inishikia hapa. Sikizeni Ruta. Falcon. Sikiza Ruta.
Headroom, no internet.
Sikiza Ruta. Yaani kamilioni wa kote kakosi. Connect na hii. Hapana, sasa kaji ukiwa. Mtini pia ndio. Connect.
Ishasema mimi nimeleft.
reactive and toxic. So even that rinsed can be corrosive. And finally, for this section of waste is a term I want to bring on board. This is satellite accumulation. Basically, collection and storage of waste. We need to be able to have the temporary accumulation and storage of waste before I give you that call that I just gave you as the lab manager to tell you that I am bringing you waste and you're asking me those questions. I should be able to collect my waste. And these small collections or periodic collections, which you, the lab manager, has a plan on for how long do you collect your waste before you take it to the facility that is going to dispose or recycle or retreat. How long? So that exercise is what we're calling satellite accumulation, just a temporary storage of waste in our laboratory. And it is important that we do this very close to the point of generation or near the point of generation. Of course, lab and where we are working in the lab, and we should have a point of satellite accumulation right close to the lab. So we do not have it at OML, and then the satellite collection is the shopping center, for example. No. So it just needs to be close there. And also need to be aware of what your intention with the waste is. Is it really to dispose it, or are you going to plan to reuse it? If you're going to plan to reuse it, then you better make a decision fast enough to reuse it. So satellite collection is the term I wanted to bring on board as I end this lesson. And the note here, which I will not bother to read because it is exactly what we talked about last time, good practices. If you can just quickly see one that you already mentioned, label the container. So this just reminds you that you have to practice or have good practices on using on handling waste. So in a nutshell, we have defined waste. What is waste? We have talked about how to store waste in our lab. When we looked at the bins, in the class we had 4 bins. We exercised ourselves on that to see what kind of bins do we have, why do we need those kind of bins, when do we need, where should they be. So all the issues about waste and the disposal. And this morning we have characterized waste. basically into 4: reactive, corrosive, toxic, and ignitable. I would like to test you on your experience with the characteristic of waste. So please get to the chat box. Okay. In your life as a chemist, you can have this from high school or your experience in KU. Which of these 4 have you encountered? So just give me a chemical waste or a chemical that you have encountered that you can classify as, and preferably waste, because the topic is waste. You can classify as toxic. You can classify as, so give it to me, write the waste that you have encountered, and now you know that you can classify it. If you were to take it to a disposal, you can classify it as toxic. You can also classify it as listed. So nipatie zile chemicals we interact with in terms of waste. Remember, a waste is a substance which we defined last time. It's no longer useful, must be discarded. So now give us the waste and write toxic. Give us a waste and write ignitable. Give us characterize waste, in other words, from the ones you have used in your life as a chemist.
Nataka kuandika propanol.
Ethanol, ignitable. Thank you, Njoroge. He has used ethanol.
Propanol.
And it's
Silikuwa
characterized
ignitable.
as ignitable.
Mama inakuwa
And
nini?
remember, when do you talk of it being waste? It's an important aspect. Njoroge peke yake ndiye ame-encounter waste that he can characterize. Proceed to characterize waste you have used in the lab. Propanol, after experiment, yes, propanol, it is ignitable. So a characteristic of ignitability is coming up from your experience. Corrosive, sulfuric acid, yes, and most acids and bases we have used, sulfuric acid is corrosive, yes. Corrosive has come up. Toxic, again, sulfuric acid is toxic, yes, at the level defined by the test, the toxicity test. Chlorine gas is toxic. That is right. That's true. And we have encountered and used chlorine gas in the lab.
Corrosive. Sodium hydroxide.
Yeah. It's a simple think through. You can write T. Toxic. Okay, go listed. Corrosive, sodium hydroxide, true. Nitric acid, ignitable. So I have seen ignitability, corrosiveness. I've seen toxicity and reactive. Oh, great.
Potassium imekuja, weka sodium pia.
I have seen reactivity. That's
reactivity, exactly, reactivity.
Some you just know them. Others, if you don't know them, you need to refer to the sheets and be able to tell whether they are corrosive. The last 10 minutes or so of this class, I'll let Prof have an interaction with you. And then on Thursday, we will do quality assurance in the lab. And that will be basically it for this course. The rest will have communication. Wapi class rep? Sijamsikia leo. Calvin? Calvin?
Yeah, I am present.
Oh, you're present. Na nimekuona kwa chat box kweli?
No.
Meaning?
I'm active.
Meaning you're inactive.
Mentimeter.
But we're asking you to participate, class rep. Why would you not participate? Can I see? I need a response from you in the chat. It is not good to say you're listening and you're not participating when it is expected to participate. active. So I noted you are not participating at all. Kwa sababu hujakunywa chai. I have asked yes, no questions you didn't answer. I have asked characterizing of waste you not answered. I also asked examples why we wash the cup you didn't answer. So I noted something is not right.
I have problems with my network.
The network is very good. You're able to speak to me. By just that little network you have, you should have been able to give me answers. Minyache, isn't it? Yeah, okay, fine. So I'll give Prof the last 10 minutes
Mentimeter.
here, and then we will move on from there. Professor?
Okay, thank you so much, Dr. Naviri and students. For those who are able to participate, I think the topic of chemical waste is quite important because the way waste is handled is actually a regulation by the government. If you don't follow the practices as told or taught by Dr. Naviri, you could be breaking the law. So somebody could end up coming from the government or county government or even national government, and the whole university could be prosecuted for polluting, for example, the rivers or the environment. So it's actually a very serious or important topic, and most people don't realize that you're responsible for disposing now, of course, in the university, but of course, the waste comes from the students. But the university itself could be taken to court, maybe by NEMA or some other organization for polluting the environment and not disposing waste properly. So looks like we have about just 5 minutes. So what I can do, I didn't want to summarize everything for you here, but overall I think for me I took quite a bit of takeaway or important points. So I don't want to summarize my points because then I'll be summarizing the class for you. So I'll give just 1 minute or two. I want somebody to write in the chat one important takeaway, one important point, or something that they will remember from today's lesson. So again, this is a good opportunity for those who have not participated today because Dr. Naviri will later on be checking to see who participated. So write in the chat one very short, important takeaway from today's class. So I'll just give a minute because we don't have a lot of time. We have only 4 minutes, and I want to make sure we are on time. So write one important takeaway, important thing that you learned from today's class. So please go ahead. We don't have a lot of time. So I see an answer there, the different characteristics of waste. Dr. Naviri gave us that acronym of TCLP, which I think something like toxicity characteristic, leaching procedure, important things that you have to consider or take into account before you dispose waste. There is characteristics of common required by treatment. Different characteristics of waste again that's coming up. What to consider when disposing waste. So I think those were the overall things. I also, in addition to that, I think one of the things for me that I don't know quite important that Naviri brought up is, for example, for waste, the pH differences, pH, low pH or high pH, both are toxic. And even something like, for example, where you dispose waste, you want it to be near where you are collecting the waste. So I think that is important. Maybe students are not aware why that is important, but think about it. If you're going to take your waste very, very far away from where you are generating the waste, then there's the danger that something could happen on the way, accident or something. So it's always good to be able to dispose your waste close to where you are collecting it. With about 2 minutes left, does anybody have a question for me or Dr. Naviri? Any question from students? Question? Comments? Again, don't forget that Dr. Naviri is recording participation to see who is actually present. Not seeing anything. So then, students, I'll be seeing you again in class on Thursday in person. So I look forward to that interaction. Dr. Naviri, over to you then to finish up.
Okay, thanks for the moment with the students. Prof will be seeing us in class as mentioned, but between now and then, there will be very short kind of questionnaire. Ideally, we come to the end of an online interaction for this semester per se, unless need arises. So we will be sending out a very, very short questionnaire regards to this unit. It's not a test. It's not a CAT. It's just a kind of a general questionnaire to find out how we have been doing in this class. Okay, so given that we will not as such have another online interaction, I think we can take our last shot of a photo together with Prof before the other one will be face to face. So let's take the online on, please. We have a guest here with us also in attendance. Please give us your comments following your attendance of the class. Send it on chat, then we will know who you are. It's someone who is also with us here. Just give us a general feedback about the time you have spent with us, the few minutes you spent with us, what you think, and we will know who you are. Chilolo peke yake ndiye kwa camera, so the rest tuweke camera on. Asante Wahome, Wangoki, asante. Let's have the Chilolo tukuone umeenda kwa giza tena. Yes, Sara alikuwa hajakunywa chai ya ukweli. Sara, wewe naona kweli hujakunywa chai. Hata Wanjiku hajakunywa chai. Hizo sura kweli. Kwani mtakunywa chai saa ngapi? Mbona at least wewe unakaa unangoja pizza. Juruge, why you a bit not active today? What's happening? Ulinipea majibu yote?
Yes.
Oh, you did, huh? You did. Gatoko, did you tell me anything? Class rep, when you know class rep. Jaribu unakunywa chai mapema. Unajua you are the best center of the class. Kipto usilale Kipto. Chai itakuja tu. Ndwati uko na mgeni? Kama ni classmate. Luvonga ready, camera on. Morgan. Meanwhile, we're waiting for comment from our guest in the house. Sarah, your camera on. I want to take a photo with you all. So wengine wako off. Muteki, Mwangi, camera on please. Reni, Dangoja wewe Muteki. Now Morgan, not yet. Na kama uko na mgeni mwambie pia jaribu kusmile kushinda wewe. Luvonga unasema nini? Odhiambo tukupati vizuri. Mkoya lips hazionekani, naona tu mapua. Songesha kichwa juu kidogo. Kidogo hiyo, that's better. Haya, sawa. Haya, so Chilolo tena umepotea. Okay, good. Najua umetufunza Kiswahili mingi sana hizi semester mbili. Okay, so one, two, I'm serious. Hata hii picha ikienda Canada wajue tu ati nilichukuliwa siku sana kabla breakfast. Haya. Hii ni ile inapelekwa Canada. 1, 2, before saa hizi tuambie kama ni mzuri ama hapana. Try a second one. Sara, sasa umejishika kichwa kama mwenye umejishika kichwa kama mwenye hakuna shida zote za Kenya. Hizi shida ziko tu Sara, wacha kufunika kichwa. Mwenye ana shida shauri yake. Sasa lazima kila mtu akuwe na shida moja ama mbili, kama ya kutokunywa chai kabla saa 3, hiyo pia ni shida. Haya. Sara, washa kamera. I take a last one. Sara, finally Luvonga, you are there. Ni vile ulikuwa hujatandika kitanda, najua hiyo ndio ilikuwa shida. Luvonga, sasa umetandika. Wewe mnatandika vitanda. That's interesting. You see a gentleman's bed neat. Good Sara, toa nini Sara, umekuaje? Hivyo. Good. Thank you very much. So we will meet in class on Thursday, as I already mentioned, and then we proceed from there. Okay, you have 6 minutes to move to your next class. Prof, you can stay on hold on the call. We can touch base. The students can kindly leave the class.